Hello, people.
Hello, hello. Abhishek, Urjit, Shriya.
Yes, sir.
Yes. So, from which college are you people from?
Uh,
Hmm?
Actually, I'm a passed out student. I've done
Okay,
my
you are
BTech from
passed out.
Uttam.
Nice.
Yes, sir.
Good, good. So, what are you doing currently?
Currently looking for job opportunity.
Okay, good, good. Urjit, what about you?
Uh, yeah, I'm from VNR.
VNR, okay. Did you attend our class? Like mine
Uh,
or Rohit sir's?
no, no. Like last time I didn't. I was busy with some other work, so I did.
Okay, okay. No problem. Shriya? Hello, Venkat. Hello. Hello, Shashank. Hello, Shriram. Hello, Shyam.
Hi, sir.
Hello. You are from VNR or some other college?
Uh, from other college.
Okay, okay. Which college?
Uh, NIT Arunachal Pradesh.
Oh, nice. Good, good. NIT? Which one?
Arunachal Pradesh.
Arunachal Pradesh. Nice.
Yes.
Hello, Tarun Sai.
Hi.
Hello. How are you? Am I audible? Am I audible, guys?
Yes, sir.
Yes,
Okay.
sir.
So I guess it's about time. Let's see, maybe more 2 minutes. After that, we are going to start our session. Okay.
Okay, sir.
Good. What about others? From where are you? What are you doing right now? What are you pursuing? Are you looking for jobs or already having job or in a college? Put it in the chat. If you can't talk, just we have the chat option na? Right there. Hello, Shweta. So shall we start, guys? Just write yes or you have raise option. Hit that.
Yes, sir.
Yes. Everyone?
Yes, sir.
Okay. Two responses only.
Yes, sir.
Good. What about Shweta? Shashank?
Yes, sir.
Good. Hey, Niranjan.
Hi, sir.
Hello. How are you?
Fine, sir.
Fine. Where are you from?
I'm from Hyderabad only, sir.
Hyderabad. Studying,
Yes, sir.
working.
Right now I'm studying in VNR VJT, third year, sir.
Okay, okay. Did you attend my class or Rohit sir's class?
I attended the Rohit sir's class, sir.
Good, good, good.
Hi, Bilal.
Hello, sir. How are you?
Hello, guys. Yeah. I want to just ask, everyone is from Vienna right now in in the session who is joined?
Yes, sir.
No, sir.
Anyone? Okay, Sriram is there. Okay.
Yes, sir.
And rest of the people, I can see Tarun and Urjit, Shweta. You guys are from Vienna, everyone?
Yes, sir.
Okay. Yeah, Bilal, you can continue that. Maybe many people more can join, but you can start. Okay.
Done, sir. Done.
Thank you, Bilal.
Thank you, sir. So, people, today we are discussing machine learning, and especially in machine learning, we will be going into linear regression. Okay. So, let how many of you understand what machine learning is? Just understand. You have a raise button over there. If you know about machine learning, what machine learning is, you can hit that so I can know how many of you are aware of that. People? Okay, few more joined. So we have just started. Okay, we are going to discuss about machine learning from the very basics of machine learning, and then we will dive into linear regression. Do you people know about machine learning? Do you people have an idea about machine learning? If yes, you have something called like this arrays, so I can say, okay, so this person knows, that person
It's
knows.
just like we use machine learning to develop algorithms that allow computers to learn from data.
Okay,
And it is a part of artificial intelligence.
okay. So you're saying machine learning are algorithms using which we can make machines do our work. Did I get that
It
right?
is it is used for developing algorithms.
It is
So
used
that
for developing algorithms. Okay. No, we cannot use machine learning to develop new algorithms, but machine learning, within machine learning, we have multiple algorithms through which what we usually do is we make machine do our task that we usually do. Instead of me doing it, I will ask my machine, my laptop, my mobile, my device, my computer to do my job. It can do it efficiently, it can do it accurately, it can do it fastly. Yeah. Anyone else? I need to understand, how you people are aware. Where should I start from? Unless I don't know who I am teaching, how can I teach you? Yes?
uh, sir,
Adwa.
my like I don't know nothing about machine learning, so we should start from basic itself.
Okay, good.
So
Others, please give your feedbacks.
It's like I don't know about machine learning.
Okay, no
Yes, sir.
problem.
We'll need it from the basics, sir.
Okay, good. Anyone from the field of artificial intelligence or data science or data analytics? Anyone like that? Like in your college, if you have such subjects, or if you are working somewhere, do you have? I think only Abhishek and Sriram are not from Vienna. Rest of you are from Vienna.
yes, sir.
Yes, I
Okay.
guess.
So no problem. We'll start from the very basics. What do you people understand by the term data? Data.
Collection of facts.
Collection of collection of
Facts.
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 Okay. Okay. More? Anyone else? Shashank, what do you think what data is? Shashank,
Collection of information, I guess.
collection of information. Good. What about Shreya? Shreya, what do you say? Shreya? Is there any problem like mic not working or something like that? Okay, no problem. So Harshita, I didn't talk to you. Harshita, what is data? Harshita, chalo, no problem, guys. Try to speak up. You know, it will be nice. See, what is the basic things that make us human? Hmm? There are few basic traits that we must have that we can point out if that person is human or not. And one
Our
of the,
senses.
yes, our senses, and the most crucial thing in humanity is talking, communicating, expressing. Others may have few parts of how we communicate, like other animals, other species, but the way we communicate, the way we talk, the way we express, it's what makes us at the top. That's a very basic trait. We learn it from the very childhood of ours. We even created sign languages for those who can't speak. So understand how important talking is. That for those who can't even speak, we created a language for them. So people, you need to speak up. You need to talk. Talking is good. You understand how are we going to express our thoughts? How are we converting our thoughts into words? So, okay. So basically, we have something called information. Okay. Then we have something called data. Everything around us, everything about us is information. My name is Bilal is information. I am taking a workshop is an information. I am taking a workshop at 8 o'clock. It's an information. Now, if I convert this information into meaningful data, to some meaningful information, this is raw information. Okay. I'm saying my name is Bilal. This is raw information. It just came out of my mouth and it is raw. Now, if I want to convert whatever I have said right now into something meaningful, then it becomes data. For example, let me share my screen. I hope the screen is visible.
Yes, sir.
So, Bilal is taking a workshop at 8 p.m. This is information. This is raw. This is something we communicate. We as humans know what this is, but how can ChatGPT know this? We type the same thing, right? Bilal is taking a workshop at 8 p.m. or we just write, hi, ChatGPT, help me with so and so thing. So machine cannot understand such language. Machine cannot understand human language, or basically we call it natural language. We call it natural language. Any human language is natural language. Hindi, Telugu, Arabic, Japanese, French, Korean, what else? German. These are all natural languages, and machine cannot understand natural languages. Understood? So what can machine understand? What is the language that machine understand? Anyone?
Numbers, binary numbers.
Binary
Binary.
data.
Very good. Zeros and ones.
Once.
Yes. Zeros and ones are the only type of data that our machines will understand. We can convert Bilal is taking a workshop at everything into zeros and ones. That we know how to do. We have something called NLP, Natural Language Processing Program. Now, if I want to convert this into data, this is information, right? Now, let us convert it into data. Let me clean this up. Now, if I want to convert this into data, I will say name, activity, time. I say Bilal is taking a workshop at 8 p.m. Abhishek is attending a workshop at 8 p.m. What do you have? Rahul is playing at 10 a.m. Now, this structured form of collecting data, this is meaningful data. Now, this if we instead of writing Bilal is taking workshop at 8 p.m. and then converting into a machine understandable language, that is way tougher than converting this thing. These things are so easy to convert into machine understandable language that we call them data. They are meaningful, they are easy to convert, they make sense to us when we look at that, they make sense to the algorithms which we use with them. Understood? So there is a lot of information around us. Everything, your school is an information, everything in within your school, the number of student is an information, the details about the student is information, the details about your faculty is information. In an company, the company name is an information, the company employees are information, the company structure is an information. So everything is an information. We try to record this information in the form of data because why is artificial intelligence booming right now? Why is artificial intelligence booming right now? Is we have data, we have plenty of data, abundant data. We have computing power, we have lot of computing power, we have funding. And for storing this data, we have large storage places, storage hardware. We have this four things collectively gave the boom to AI. AI, the term AI was coined in 1951. The term AI was coined in 1951. So understand this started way before we were born. It started way before anything about artificial intelligence was known publicly. Why did it not boom back then? The answer is there was not enough data, there was not enough computing power, there is not enough funding from government or private sector, there was not enough storage area. Understood, people? Now, if I have great computation power, great algorithm, the best hardware, but if I do not have data, this all goes for nothing. This all goes for nothing. It means this won't have any purpose if I do not have this. Everything that we have right now, every infrastructure that we have right now, every artificial intelligence model we have right now, not just artificial intelligence, any business that is set up right now, any big companies there are right now, it is because of data. They analyze data, they build insights out of data. They gain insights, they gain the knowledge that they need. If I want to establish a startup, the main thing is collecting information, converting that into data, and then gaining some knowledge from it. And based on that knowledge, I need to set up my startup. So data is everywhere. We need data. Data is so essential that without data, everything will collapse or everything will not have any purpose. Data is knowledge, and knowledge is what drives innovation. Knowledge is what drives innovation. So that is how important data is. Without data, you can't do anything. You have information, like I said, we have information, we convert it into data. And during this conversion process, there is a lot of anomalies, discrepancies, mistakes, errors that happen. And if we make that mistake, our data becomes unclean. And again, if you have unclean data, you cannot train your models, you cannot gain insights, you cannot gain knowledge. Rather be human or machine. If the data is unclean, neither human nor machine can gain any kind of information. Understandable, people?
Yes, sir.
Yes, if you have any doubt, if you have any other inputs, not just doubts, you can talk, okay?
Okay, sir.
Others too. Not just Abhishek. Abhishek, I guess you also attended the
Yes,
previous class. Aman sir, took, right?
Yes, sir.
So others also talk. Harshita, Shweta, Shreya, Niranjan, Shyam, Venkat. Please talk. So this is data. Okay. Complete machine learning is based on two things: algorithm, data. Machine learning is what we are making our machine learn, to do tasks which human do. Learn to do tasks which humans do. Learn to do tasks which we humans do regularly. Previously, we used to predict, if I wanted to predict stock market prices, I would need to sit down, have an Excel sheet or a physical record before me, and then I need to compute, I need to calculate, I need to do all this analysis, and at last I will make some prediction in stock prices of Amazon, stock prices of Apple. I need to do it manually. But right now we have so many algorithms in machine learning which will do this job, this entire hours and hours of job within few minutes. Within few minutes. Hours or days. People would spend hours, days to predict stock market prices. Now it takes only few minutes. That's how we are teaching our machines to work. So what is AI basically? What is the concept of AI? Make machines do, feel, think like humans. This part is still under controversy. Few scientists say that it has self-consciousness or self-awareness. AI that we have right now, few say it is just data. AI is so complex, guys. We have created AIs. We have created neural networks. Those are so complex. You feed data, same. You feed data to your model, your artificial intelligence model. They learn from the data. They learn from the data. Until a point, you will understand how this machine is learning the data. But when you get to a certain point, even we as human cannot interpret how is machine able to understand the data. Maybe here, till here, you can see what is going on. But once you reach a point, it is unknown. It is black box. We call it black box. How is machine able to do this? We created something, but we cannot understand what it is. That's how complex our AI models have become. That's because we have abundant data, we have good algorithms or great algorithms, and we have so much computation power. Now, machine learning, we understood. We teach our machines to do our job. There are different ways of teaching this machine. Something called super supervised learning. There is something called supervised learning. There is something called unsupervised learning. There is something called reinforcement learning. Reinforcement learning. Then is something called semi supervised learning. Semi supervised. These are the major approaches that we take while training our machine. Got it? Got it, guys?
Yes.
Is the flow
Yes,
okay?
sir.
Yes.
Shashank? Shashank? Shweta? Niranjan?
Yes, sir.
Okay. Is it understandable? Harshita? Harshita? Shyam? Is what I have taught right now, is it understandable? Shreya? Priya? If you guys have problem talking, you can put it in the chat, okay? You have a chat icon, you can put it there. Okay, let's continue. So we have these approaches. Number one is supervised. Supervised says you have data. Sorry guys, no, just a minute. You have data which is labeled. Labeled in the sense, for example, name, name, okay, name and city, let's say age, let's say salary. This is labeled data. This information you have like name, what can we put it? Name Bilal, Gupta, Harish, etc. etc. These things we are labeling it as names. This information, this data, Hyderabad, Delhi, Mumbai. This information is labeled as city. 10 years, 18 years, 20 years, 50 years. Age, same goes with salary. This is labeled data. We know what data we are working with. We know what are we going to do with this data. For example, based on the age, based on the city, I want to predict the salary of given person. Based on age and based on city which they are living in. I want to predict, I want to understand how much salary they can have. That's possible. That's very possible with the algorithms we have right now. I can just give the input of my city, my age, and I can say just predict the average salary this person can get. So I know my input variable, my input variables, and I also know my output variable, my output variable. Let me clear this. Okay, guys. Supervised, unsupervised, semi-supervised, reinforcement. Here we have labeled data. We understood what labeled data is, something which we have in this way. Something, this is a label, this is data. This is label, this is data. This is label, this is data. This is label, this is data. These are the input labels for now. I took this as input labels. Based on this, I will predict my target or my output. We either call it target or output. Okay, guys? That is label data. We feed our machine with this data, our algorithm with this data, with such labeled data, and we get an output. Understood?
Yes.
Good. Now we have unlabeled data, where Here we have information about what data we are dealing with. Here we do not have that information. For example, you have an image, a cat image, cat image. If I put this into my chat GPT, will it be able to say it is a cat image? Will
Yes, sir.
ChatGPT or any AI model, can they predict that given image is dog image, cat image, human image? We have even advanced model. If I just give them my photo of my bag or my laptop or my sweater or my jacket or my t-shirt, they can predict the brand, they can predict the cloth, they can predict so many things out of just one picture. They are able to get information from this one thing. Here you establish relationship between data. Here you do not know what is this. This is basically pixels now. An image is combination of pixels. How can you label each pixel? You can't. So what are you going to do? What is your model going to do? The model is going to understand the patterns, pattern recognition. It is going to understand the patterns within this image. Is it clear, guys? Here we are trying to establish relationships. Here we are trying to establish pattern. Got it?
Yes.
Semi-supervised is hybrid version of supervised and unsupervised. Basically, we have few few data, few labeled data. You train your model onto this. Then you also feed it unlabeled data. Based on this labeled data, whatever you have trained it on, it will try to understand this labeled data and learn from it. And then your model is ready. First, it will be trained on labeled data. Then it will go, we will feed it some unlabeled data. Then it will understand, okay. For example, I give a data about human part, right? Eyes are in so and so dimensions, eyes are in so and so shape, eyes are in so and so location of the body, nose, etc., etc. I try to make it understand the basic mathematically I will tell it how eyes are, what are the shape of the eyes. I will tell it where it is placed on our body. I will tell it how it is placed. I will tell it it can have multiple colors. I will give it some labeled data. Then I will give some unlabeled data like images of human. Then based on this labeled data, it will understand this unlabeled data. Got it? Got it, guys? Was that clear?
Yes, sir.
Yes, sir.
Labeled and unlabeled. Other people talk, please. Now, reinforcement. This is something your Tesla, your autonomous cars, your autonomous systems, your robots, your drones, they all use this reinforcement learning. Automobile industry, drone industry, robot industry. Basically, you first make an algorithm. You put this algorithm into your machine. Your machine do the task. Your machine does the task. Okay. Now, there is 100% chance that your machine initially is going to make mistakes. Initially, your machine is going to make some errors. What you will do, you will give feedback. You will give feedback in the form of reward, in the form of reward or punishment or penalty. If it does something right, you'll say plus 1 point. You have done right, keep going. If you do it wrong, -1 penalty. I will punish it. I will punish the machine So if I created a robot, if I created a robot, I want the robot to go in this path. This is the path, this is the start point, this is the end point. I want it to follow this path, this particular path. Now my robot will start from here. It will go like this, like this, like this, and it will start keep going. I will stop it and say you have done wrong, -1, go back. It will come here. It will go again, go here, here, here. It will go like this. I'll say no, -1. It understands. Come back. Goes like this. I say +1. You have done something right. Keep going. It will go like this. I'll say +1. It goes like this. I'll say +1. If it keep going like this, I'll say -1. Then it will come back to this point. Then it will go like this, +1, +1. If it keeps going and do this, -1. Again, it will come back to this point. Go like this. Okay, +1. Go like this, +1. You have reached your point. Your job is done. Now here we have human feedback. We give human feedback and we train our machine. We created chessboards, AI chessboards. We created AI cars, autonomous cars. We have something called AlphaGo. AlphaGo is also a board game. We created that. We created AI-based drones. So many applications of reinforcement learning. And in this particular field, this defeated the world champion we called Grandmasters, GM. Cars became much wiser. Just a minute, guys. This was from- Just a minute. They have become better than humans at driving cars if it is foreign country. Because in India, how are you going to train your cars to go if there is a pothole, you go like this. If there is you go straight, but there is small gap here, so a bike rider will come and overtake you. So these are the patterns that we cannot make our car understand, our algorithm understand. In the foreign, they follow a particular lane, they follow particular speed, particular rules. So it is easy for them to implement such algorithms which they can put in their cars. But when it comes to us, we cannot do it because there is a lot of complexity, lot of variation in the data. How are you going to train for, sometimes there is a construction, how are you going to train your car, no, or there is some shortcut there, go from there. So it is not possible. That's the reason we cannot have autonomous cars in India. Then we have drones. Then we have this thing to it also defeated its what do you say, champion, world champion. So that's how advanced we are creating this model. Understood? Supervised, unsupervised, semi-supervised, and reinforcement. Let's get into supervised. In supervised, we will talk about linear regression particularly. Because this thing is foundation. This is where everything started. It's like our, have you seen Iron Man? Iron Man. Guys?
Yes, sir.
Yes, sir.
Yes. Shweta, do you know Iron Man? Venkat is on hold from so long. Where is he? Okay. Yes, Shweta. Shashank.
Yes, sir.
Yes, you know, right? What was the first suit of Iron Man? First suit that he created in a cave. Anyone? No Marvel fans here? Okay, it was
No,
called
no, sir.
Mark 1. Okay. Have you seen the movie, guys? Iron
No,
Man
sir.
movie? No? Okay. Anyone else? Have you seen Iron Man movie? Are you fan of Iron Man, Marvel?
Yes, sir.
Yes, right. So Mark 1, was it best? The best Iron Man suit?
No.
No. But it laid the foundation for all the other suits. Tony Stark became Iron Man because of Mark 1. The same way linear regression led to the world of artificial intelligence. This particular algorithm, it is used everywhere, especially in deep learning. After machine learning comes deep learning, it where what we do is deep learning means what scientists did is the thought. Okay, if I want to make my machine think like human, why not replicate human brain? Human brain have neurons through which they communicate. Human brain have neurons. So what I will do is I will make an artificial neural network. Artificial neural network. We have neural system, right, in our brain, which does all the communication. So now scientists thought, okay, the researchers thought, if I want my machine to think like me, I will just make an artificial neural network which I will put into my machine so that it can think like human. That's deep learning. In, and everywhere in deep learning, you will see linear regression. Everywhere, everywhere. So guys, linear regression. If let's say, I have come out of my exam hall, I want to predict, I want to predict my marks. How much, how much could I have scored? For the researcher exam, how much can I score? A simple question. Just now I have written my exam. So how much? There are multiple factors. How many hours did I study? How much interest did I have on that? How much well behaved you are with your teacher? If you have bad relation with your teacher, they will reduce marks. If you have good relation, they will increase marks. How much efforts did you put, etc. And so many other factors. These are factors. These factors will decide this thing. Got it, guys? It is simple. What we have discussed right now is simple. I want to predict my marks. I have just come out of my exam hall. And I want to predict marks. And when I was doing so, I understood there are multiple factors. So I took one factor's hours. I took only one factor. And based on this, I wanted to predict my mark. Predict my mark. So what I did, based on already past information, I have some past information that somewhere in the past semester I have studied for 2 hours. Okay, the exam is for 15 marks. So I have gained 4 marks. Oh no, let's wait a little. Let's say 8 marks. I studied for 4 hours. I got 12 marks. Let's say 6 hours. I scored around 14, and for one examination I studied for 7 hours. 7 hours, and I scored 15 out of 15. This is already noted information. This is actual information. This is not something you got out of your brain. You're just writing it out of nowhere. No, this this happened. This is actual data. This actually happened in the real world, and you noted it down. Okay, you noted it down. Let me see if I can do one thing. Okay. No problem. I wanted to have this, but okay. Mm. No problem. So this is actual information. This particular thing is actual information, actual data from the real world. Okay. Now, based on this, I want to understand right now. I studied for 3 hours. How much can I score? Hmm, Guys, a simple question. What is this? It is from your intermediate.
Equation of a straight line.
Very good. It is the equation of straight line. And guess what, guys? This is the thing we use for predictions. For prediction. Just imagine while you are studying your intermediate and you got to know about linear algorithms, linear algebra, and you came across this thing. You thought, okay, what is this? Y is equal to mx plus c. I won't even see this in my entire life. But this thing laid the foundation for machine learning, deep learning, and the AI we know right now. And in our machine learning or in our AI world, we write it as Wx plus B. We write it as Wx plus B. This is weight, this is bias. And the whole AI world is going after weights and bias. Because this these two things will define the accuracy of your model. Only these two things. Now, I am saying this is my y. I want to predict my y. I want to predict my y based on this x data. Based on this x data. So I want to predict my y based on this x data, and with on that x data, I will put some parameters like w and b. Hello, Mani. Hello, Keshav. Keshav. Okay. So weights and biases. These are the things which will define your accuracy, and based on this x input, I want to predict this y output, and I will put some parameters over it. Some parameters over it. Let me erase this. Now, what I'm saying is, I'll give this input, predict this output. Now, I will also consider, how much influence will this input have on my output, and that influences weight. What is the weightage of this input? That means, what that means is, if I am considering this as a factor to predict my marks, how much importance does it have? For example, there are multiple factors like we said: hours, efforts, and teacher, your connections and your relationship with teacher. I am saying out of 10, or on the scale of 0 to 1, this particular thing has 0.8% or 80%. You say 80% influence. This has 90% influence. This also has 90% influence. So this influence, we can represent it as 0.9, 0.8, something 0.1, etc., etc. So this weightage will define how much influence will my input X will be having on my input Y, output Y. Understood, guys? Was that understandable?
Yes.
Any doubts? You can ask me. Because we are going into the mathematical stuff of algorithms. So if you have any doubts, stop me, ask me, or even if you have now, ask me. Everyone, please. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. Others? Niranjan? Niranjan?
Yes,
Prashant?
sir.
Shreya? And I guess others left. Okay. Others who joined aren't here. Okay, no problem. Shweta is not there. A few other I don't see. Okay. So these are my weights. Now that defines my influence. Weights defines the influence of my input value X. Now, guys, is my marks are my marks dependent on this variable X? Dependent? Are they dependent? How much marks I will get, is that dependent on how many hours I have spent studying that? Yes or no? Is it dependent or not? Right?
Yes.
Yes, right? So I'll call it as dependent variable. Simple. The term, the what do you say? Technical term for this y variable is dependent variable. Got it? And this x term, it is not dependent on my marks. It is not like if I get so and so marks, if I get 8 marks, then I will study for 2 marks. That doesn't make any sense. That doesn't make any sense. This is independent. This is independent. This is independent, and thus we call this thing independent variable. And in linear regression, you can have n number of w1 x1 plus w2 x2 plus w3 x3 plus so on till wn xn plus b. You can have multiple independent variables because there will be multiple factors that will be affecting your y. But right now I have only taken one out of it. For the simplicity of understanding, I have only took one variable. Got it, guys? What is independent and dependent variable?
Yes.
Yes,
These are
sir.
dependent. Sorry, my bad. This is our dependent variable and this is our independent variable. Sorry, not this. This is our weight. This is our independent variable. Now, let's put a graph. 8, sorry. 2, 4, 6, 7. These are my x that is ours. That is ours. And this is my y, which are my marks. Okay, which are my marks. If you plot it, we get something like this. If I plot it, I get something like this. Now this particular thing, let's say, okay, how we can't do graph this. Sorry, my bad. We need to have periodic growth. For this, I will put again 2, let's say 4, 8, 12, 16. Okay. And based on this, we will have a graph. My graph starts from here. It goes like this. This is the slope, right? This is the slope that this is straight line and we can have its slope. This thing, this particular thing, this thing is called intercept. In mathematics, we call it intercept. That basically means from where is my minimum value going to start from? My marks value, what is the minimum value where it will start from? For example, my minimum value, I can also put it like this. I can also put it like this. That means my minimum value is 0. What does that mean? I'm saying that if anyone writes an exam, the minimum marks they can get is 0. If I start from here, I'm saying if anyone writes the exam, the minimum marks they will get is 8 marks. If I point it out somewhere here, -1, let's say. If you have negative ranking in marking system, that means if someone attempts an exam, there is a chance that their minimum marks can be -1. That's called intercept. Where does the minimum value of my y variable going to start from? And that is called bias. In mathematical terms, we call it intercept. In machine learning or AI terms, technical terms, we call it bias. Understood, people? You understood what weights are, what dependent variables are, and what bias is, right?
Yes.
Yes.
Good. Others? Shashank?
Yes, sir.
Yes, any doubts? Any doubts? Okay, no problem. So, again, let's erase this. Erase this. You understood what y is. You understood what x is. You understood what weights are. You understood what y is. Good. Now, guys, let's do one thing. Let's make use of this and predict our marks. I say, I want to predict my marks if I studied for 2 hours. We already have the data, but right now we are predicting, okay? We are predicting. So what I will do, I will initially set weight and bias as 1. Okay? Initially, let's say my weight is also 1, my bias is also 1. What's the output, guys? 2 plus 1, that is 3. Now, tell me, guys, tell me, how many hours did we study? 2 hours. What is the prediction? 3. But what is the actual result from the real world that we know? 8.
8.
So my prediction has gone wrong. What I have done is wrong, which means this is my algorithm right now. This thing is my algorithm right now. This algorithm has committed some error. This algorithm has committed some error. Why are people leaving? Is there any problem? Suddenly 3 people left. Okay, maybe network issues. So right now my model or my algorithm has committed some error. Now what I should do is I need to find out error. How much error? I'll say take the predicted result. I will call it y dash. I'll call it y dash and take my actual result. My actual result, I will call it y. and calculate their difference. Their difference comes out to be 8 minus 3 or 3 minus 8 in my case. 3 minus 8 minus 5. Now guys, can error be in negative? Let us understand. If uh, how how are we going to loss? If you're going to talk about loss, okay. Whenever we talk about loss, we say I have a loss of 20%. Do I use the term minus 20%? No, because loss itself is a negative term. Error itself means there is some negativity. We cannot add more negativity to negativity. So we cannot have this minus. What can I do? There are two things we can do. Okay. First thing, there is a function in mathematics which we call modulus. Right? What is modulus? Modulus. What is modulus function?
It gives the absolute value of the digit.
Yes, absolute means if it is a negative value, it will give us the positive value of it, and if it is a positive value, it will return the same thing. So right now 3 minus 8 will also become plus 5. This is one thing. But in the coming process, there is more process to it, but in the next process, this modulus will give us some error. This modulus will give us some problem. To counter that problem, what I can simply do is I can square this. Now, what is minus 5 square? What is minus 5 square?
25.
25. I've got a positive output. And also, what I have done is I have increased the error rate. This my error. I have increased. It was 5, but I said it is 25 now. Now, what is this doing is, like us humans, we are making machines like us. Okay. Our algorithms make machines like us. Basically, we are replicating ourselves. So whenever there is small error, very small error, like 0.1 or 0.8, a very small error, my machine will say, okay, it is very small now, let's neglect it. Let's leave it. Like in our life, if there is something very minor mistake we have done or minor thing that is happening, we say, let it go, let it be. So my model will also do that. But I do not want my model to do this. I want it to also remove this kinds of error. So what I will do, I will square them. I will square them. By squaring, what I basically do is I increase its quantitative value, and by that my machine thinks, okay, this is some error which is having more influence on my result. This error is having more influence on my result, so I also need to rectify this error. This is the job of square. This is the first job. There is also another thing that it contributes to, that we will understand later. Till here, is it understand? Sorry, did you understand, everyone?
Yes, sir.
Yes,
Now
sir.
what we can do is we can take the average of it. We can take the average of it. I'll just multiply it with number of inputs I have. Number of inputs I have. Here right now I have 4. I will put 4. If I have 8 inputs, I will put 8. If I have 100 inputs, I will put 100. Got it, guys? So basically I will put n, 1 by n. So I'll get an average, or the average error my model is computing throughout the process. Understood, guys? Now, what do we do with this error? Okay, I have got error rate. What should we do? I have got the loss. And basically, guys, this particular thing is called as where should I write it? My canvas is too small. I need to change this. No problem for now. for now 1 by n. Okay, y minus y. This is called mean absolute error. We are taking mean, this is absolute, and this is calculating error. Mean absolute error. And if I put squares, this become mean square error. There is something called root mean square error. There is something called R square. There are so many error functions. These are loss functions or error functions. These are called loss functions or error functions. Basically, which are used to calculate the loss or the error that is done by your model, by your algorithm. Got it, guys? Clear?
Yes.
Yes, sir.
Good. There are only 7 people here. Okay. Okay. So we were calculating, we took weights and biases randomly, a random assignment we did. So we got a wrong result. So based on my error, I have something called, sorry, my bad. What was that called? Error function, and then we have optimizers. We have optimizers. Basically, I will give my error. To this optimizer. I will give my weights and biases to my optimizer. What my optimizer will do is, based on my error, it will update my weights and my biases. What's the time? Okay, the time is almost up, so I cannot discuss about optimizers. Maybe tomorrow we can continue. So my optimizer, what it will do, it will update my weights and biases in a way that my accuracy increases. Now let's say my optimizer, what it did is, it updated the weights. The W new, the new weight, it said, okay, it was initially 1, now put it as 2. And my new bias, it says also put it as 2. These are the new best values, new values for your weights and biases. Okay, I say, okay, I will take that. My weight, I will convert it into 2. I will put it as 2. Then I will say 4 plus 2, which is 6. Did my result got better? Did my result get better? It was initially 3, then
Yes,
it
sir.
became 6. It has come closer to my actual result. I'll say, see, there is some error again. There is some error. If I do 8 minus 6, there is 2. If I do the square, there is 4. This is my error. I do not want this error. Then I will again send it to my optimizer. I'll ask my optimizer, come on, give me some new values for W and B. It says, okay, take W value as 2 again. It was good. Or we can do one thing. 4, put your B value as 0. It will not always increase your values. It can also decrease your values. It can also make your values better based on how you're treating your optimizer. There are different optimizers. There are so many optimizers. There is gradient descent, one of the most famous, one of the initial optimizers that came into picture. Then we had stochastic gradient descent, we had minimatch gradient descent, we had RMS prop, we have RMS prop, and the best optimizer that we have right now, it is called Adam. It is called Adam. It is called Adam. The best optimizer that is currently present that we use right now is Adam. I'll choose one of this, and the choosing of your algorithms, the choosing of your optimizers, the choosing of your loss functions, the choosing of your, this is one of the algorithms of machine learning, linear regression, the choosing of your machine learning algorithm. These completely defined your accuracy, not just one thing, not just one thing. Your choice makes the difference. Your choice completely changes the output of your result, of your problem. It completely changes. For that, you must have knowledge. For that, you must do research. Every solution starts from research. Every solution. People spend months in researching, months, not days. So people spend days and days and months to do research, and then they will start working on the project, on the product, on their solution. So choice makes difference. Hello, Srija. Hello. Okay. So my model said, okay, take this as 4, this as 0. Take it. So we will take it. Okay, no problem. You gave us some new values. I will put those new values, and for 2 hours, my weightage is 4, my bias is 0, I got 8, which is accurate to my result, which is my result itself. There is no error left. Now this is achieved by optimizers. What are optimizers? Algorithm. What are algorithms? Maths. Complete AI. Complete AI is maths. Everything in AI is maths. The core of AI is math. I'll show you one thing, wait. The importance of mathematics, I'll show you it. Let me share my screen. System. Drop it. Bansal. This guy. This guy, he's from India. How much package he got is 800 crores per year. 800 crores per year from Meta. He was hired by Meta. Meta came to him and asked, please join us. We will pay you 800 crores per annum. What were his qualifications? His qualifications are PhD in, not this one, not this one, yes, this. His master's was in science, which was integrated in mathematics and statistics from IIT Kanpur. This thing, mathematics, statistics, probability, linear algebra, these things are so necessary in the world of AI that it will land you a job of 800 crores if you achieve such mastery. Okay, that's the problem with today's generation. That's not the why is this happening? The problem of job, the problem of not finding the job that we want. Why is this happening is of our education system. It is because of our education system. Because we are fed with so many things. We are fed with so many things. We when we get into college, we should know Java, we should know Python, we should know C, we should know C++, we should know other things, we should know data science, we should know data analytics, we should know everything. That's not the right way. You having knowledge of everything is okay, but if you cannot master even a single thing, then no one is going to ask you. No one is going to give any, what do you say, bhav we say, no, in Hindi. No one is going to give you any damn attention if you cannot master even a single thing in your life. That's the problem. That's the problem. When I see students, they don't know what they want to do in their life. When I interact with them, I ask, what is your career plan? They say, I don't know. They say, I want to become front end. I want to become software engineer. Okay, what do you want to do in software engineer? There's so many things. There's so many things that you in the world of software engineer that you can do. You must know Java, you must know Snowflake. That's one part. Python and AI and this thing that will create you other than software engineer job. There's so much that people, first of all, they do not have the basic idea. They do not do their research, students itself, and our education system, it is completely flawed. So guys, find that one thing you want to do in your life. That one thing, just one thing. Focus on that one thing throughout your journey of your college. Even if your college is done, doesn't matter. It doesn't matter. Find that one particular thing. Okay, let me continue. There is a little more, and then we'll continue tomorrow. A little more is left. Where is it? Where is it? Hmm. Good. Optimizers will give me best W and the best B value. At last, at the end of the process, I will have the best W value, I'll have the best B value. That is my best weight, my best bias. And every time we are going to initialize our W and B randomly. Every time, every model does it. We have some new techniques. It will be a random assignment, but based on the data. Okay. It will not just give 1, 0, 2. We'll do a little bit of calculation and then we will assign. But again, this initialization of weights and biases, initially that they won't give us the result that we want. They cannot predict. They cannot predict. So what do you need to do? You must do the following steps. You must do the following steps. You must run your algorithm. You will find error. When you find error, feed it to your optimizer. Your optimizer will give W and B, new W and B, W new, B new. Then you will feed it to put it into your model. Then it will produce some result, calculate the error, put it to your optimizer, and continue this loop until you find the best W and the best B value. That's how things work. That's how a simple linear regression is the simple algorithm. Very simple algorithm, but the foundation of everything. Here where everything started. Got it, guys?
Yes.
Yes, others? Others?
Yes.
Yes. Shreya, Niranjan, Shashank, Shrija.
Yes, yes.
Yes, sir.
Shrija, you were late, way too late, I must say. You joined at 9:20. Don't worry, don't worry. We will put it on YouTube. We will have this recording on YouTube. You can watch from there, but try to be in the class. We can have an interactive session. We can interact, we can talk. Okay, guys. So that was linear regression. That's how a simple equation of straight line is used for predictions. But there are limitations. Of course, there will be limitations because this is way too simple. This is way too simple model. Very simple. So it will have its own limitations. To achieve or to remove these limitations, we will have new algorithms. We have polynomial regression. We have logistic regression. We have decision trees. Based on decision trees, we have random forest. We have a naive Bayes theorem. Do you know naive Bayes theorem? Yes, guys, Bayes theorem in probability. You must have heard it.
Yes.
Based on that, we have an algorithm. So basically, what is this AI? Everything in AI is mathematics. Everything. Every single algorithm is mathematics. Your base, linear algebra, statistics, and other parts of mathematics like probability, differentiation, derivation, integration. These all collectively, not just one concept. You put the concept of y is equals to mx plus c. You put in optimizers, you use differentiation, partial differentiation to be particular, partial differentiation in our gradient descent model. In our gradient descent model, you use partial differentiation. Loss function, you're using square, you're using mean, that is statistics. You collectively use this to produce a simple machine learning model that is called linear regression, not this thing. Everything in this world of AI is mathematics. When you will get to know more about, right now we have something called transformers, we have something called RAG, we have something called GAN, we have something called agentic AI. These all things, what are they? They are just mathematics. We found a way to convert these mathematical formulas into algorithms, and then we found a way to train these algorithms. We give these algorithms to our machine, then give the data, and based on the data we will train our machine with the help of the algorithm. That's entirety of your artificial intelligence. Data you have, mathematics algorithm you have machine, that means your computation and your storage, and that's it. Got it, guys? So this was linear regression. Got it?
Yes.
Others? Was this good? Was this session good?
Yes, sir.
Yes, right. Any doubts? Ask me, not just about this subject, any doubts other than this subject also you can ask. No doubts? Should we end the class then? Yes, guys?
Your wish, sir.
Yeah, I mean, it's up to you people. If you have doubts, if you want to talk, if any one of you, if even Shrija, you have joined late, but no problem. If you want to have any other talk, any other conversation, we can have. It's up to you. Up to you people. I can end the class right now. It's not a matter of fact. The thing is, are you people okay? Did you gain any knowledge? Do you have any other doubts? If it is all done, I can just close up. I can just pack up.
No doubt, sir.
No doubts? Okay. Others?
No doubt, sir.
Okay, guys. Good. Ask your friends, to join the classes. These are free workshops. What's the harm? No problem. Whoever missed today's class, we will be uploading a YouTube link. You will put a YouTube link into your group. Ask your friends to watch it. They'll gain some knowledge. You people, if you want to revise, watch it. People who have joined late, you can watch it. So that's it, guys. Thank you. Let's meet tomorrow. We'll have a hands-on. Okay, guys. Before coming, have these following things. First is VS Code or Google Colab. Anyone, any one of this. Install Python. Install Python. And what else do you need? That's it, I guess. Yes, that's it. Make an account on Kaggle. Kaggle. Here you get datasets. Datasets, basically collection of data. On this dataset, you train your machines basically. These are the already existing datasets that you work that you train your machine on. So create an account on Kaggle, install Python, download VS Code, or have Google. You don't need to download Google Colab. It is available on your browser itself. Just search Google Colab and get it. But if you want to continue this journey of coding and AI, having VS Code will be better. Google Colab, both. If you ask me, you must have both VS Code and Google Colab. Python installation is necessary. This account, it's up to you. Creating is better because we will be working on datasets tomorrow. So that's it, guys. Thank you. These three things are prerequisites for tomorrow. If your friends are joining, tell them. Ask your friends to join. We'll have a good session. Thank you, guys. Bye. Have a good night. Bye bye.
Boys.
Yes, you all can leave.